Hi everyone, today we're looking at problem section 7.2, and we're talking about working the system, which is going to be systems of linear inequalities. Now, this lesson in particular has a lot of writing in terms of setting up the problem, so feel free to pause the video to keep up and make sure that you're getting all the information into your notebook. If we don't understand the type of problem scenarios that exist for these specific concepts, then we won't be able to answer them correctly. So the learning target for today says I can write and solve systems of linear inequalities to be able to determine the solutions. And we're going to focus on problem number 1. So this particular problem says Chase is an experienced whitewater rafter. And he's going to guide groups of adults and children out on the water for these rafting adventures. So the super raft that he uses can hold 800 pounds of weight. Any weight greater than 800 pounds is going to cause the raft to sink or hit rocks or etc. So Chase estimates that the weight of each adult is approximately 200 pounds, and the weight of each child is approximately 100 pounds. We also know that Chase charges adults $75 per ride and children $50. And his goal is to make at least $150 per trip. So we have a lot of information here talking about really the weight of the raft and also the amount of money that Chase is going to make by hosting these whitewater trips. So part A, we're going to write an inequality to represent the most weight that Chase can carry in terms of the rafters. And we also need to define our variables because we have not done that yet. So first of all, is if y is equal to the number of adults and x is equal to the number of children, let's write the inequality thinking about the weight that the raft can carry. So each adult is approximately 200 pounds. Each child is approximately 100 pounds. So 200 per adult times the number of adults plus 100 per child, so times the number of children, is going to be less than or equal to 800 pounds because the raft can only hold 800 pounds. So whatever that total weight is needs to be less than or equal to 800. Now we also need to write an inequality to represent the least amount of money that Chase wants to earn. So Chase wants to collect a certain amount of money for each trip. If you look at our given information, it's about $150. And he's charging adults $75 and children $50. Now what we need to take into account as well is that we actually have to count Chase in the number of adults because he's obviously not charging himself to go on the rafting trip. So don't forget to count Chase. And the way we do that is we say, okay, we're going to charge $75 per adult, but not for Chase himself. So the number of adults minus 1. Number of adults minus 1 plus the number of students or the number of children times $50. And that cost we want to be greater than or equal to $150 because Chase wants to earn $150 on his rafting trip. So moving on, we want to kind of think about how we're going to graph this inequality. So first we need to write the system. We have both of our linear inequalities. So we just need to put it in the correct notation with the bracket and both of our equations. And then we want to think about graphing. So let's look at a couple of solution options. We can think about whether or not certain scenarios are solutions to the system. So is it a solution if Chase takes 5 adults on the rafting trip? So if he has, is it a solution if he takes 2 adults and 2 kids? If he has 2 adults and 2 students, that's going to equal 600 pounds, which is less than or equal to 800 pounds. So that's good. And in terms of the amount of money he earns, again, he would earn $175, which is greater than or equal to $150. So that is a solution to the system. Now, is it a solution if he takes 5 adults? If I plug in the 5 adults and I plug in a 0 for number of children, I get $1,000 or 1,000 pounds of weight for the raft, which is over the limit of 800 pounds. So he can't physically carry 5 adults in his whitewater raft. There's no point in using the second equation because we already know that the first equation will not work. So it's not a solution to the system. Now let's take a look at the graph. Graphing inequalities are actually kind of fun because we're just using the linear equation formula like we normally do when we graph lines. But we get to color code them and we get to really see the solutions in a visual way. So when I look at graphing inequalities, I'm going to just draw a graph that is from positive 10 to negative 10 for my x values as well as my y values. The tricky part about graphing in this particular situation is that these equations are not in slope-intercept form. So I could find 2 solutions to the equation, to each equation, and plot those points and then connect the points. Or I could rewrite the equations so that they are in slope-intercept form. So I'm going to choose the latter. I like to have my linear equations or inequalities in slope-intercept form when I'm solving. So by moving the x term over to the right-hand side and then dividing by 200 to remove that coefficient from y, I get a y-intercept of positive 4 and a slope of negative 1/2. So I draw my line. And because my inequality is less than or equal to, that is going to be a solid line. I'm going to do the same thing with my second equation. I'm going to distribute that 75. And then I'm going to move the constant 75 and the x variable to the right-hand side of the equation. And then I'll divide by 75 as a coefficient to y. And I get y is greater than or equal to negative 2/3 x plus 3. And I can graph that line. So now I have the two lines that help me to represent my inequalities, but I need to decide what side of each line the solutions exist on. So again, the trick is to check the origin or check the point 0, 0. So when y is equal to 0 and x is equal to 0, is the inequality true? So if y is 0 and x is 0, basically what I have is 0 is less than or equal to positive 4. That is true. So the side of my line that includes the origin is going to contain all the solutions to my inequality. With my second equation, again, I plug in a 0 for y and a 0 for x. So essentially I have 0 is greater than or equal to positive 3. That is false. So I'm going to shade in the side of the line that does not include the coordinate 0, 0. Notice how the colors for my inequality solutions overlap. Where my solutions overlap is the solution to the system. So any coordinate point that falls within that range is my solution.